Hi, my name's Callie Shelton, and today I'm going to teach you how to do half-life problems. So when you have a substance and you have the entire amount of it, 100% of it, half-life basically means, half-life explains how long it takes for a substance to reach half of its initial amount. So there's actually a formula we use to do this, and I'm just looking at my notes right now. This is the formula. This is the remaining amount. This is the answer that we're trying to find. This is the initial amount, like the entire thing, the entire substance. This is just 0.5 or 1/2. This is the time that it takes, and this is half-life right here. So that's where we plug everything in. And so now we're gonna do our first problem. Let's see. This is more of an easier problem. So let's say we have 200 grams of something, and we are trying to, the half-life of it could be 5 years, and we're trying to find how much of it remains after 15 years. So we don't know the remaining amount, but we do know the initial amount is 200. We're going to put 1/2 in there, and we're going to put 15 years divided by half-life, which is 5. 5 years to reach half of it. So this is what it looks like. And let's see, we're going to solve the exponent, which is 15 divided by 5, which is 3. And then we're going to solve this right here, which is 1/2 to the third power, which is 1/8. So now we have 200 times 1/8, and that equals 25. So it takes a 200 gram substance to reach 25 grams after 15 years. So it's pretty interesting. Here's a harder one. So let's say we have 500 milligrams of something, and we know that the half-life is, let's say, like 4 hours instead of days or years. How long until only 62.5 milligrams remain? So that is our initial amount right there. I mean, our remaining amount. So as you can tell, we're missing the time amount. We're trying to figure out how long it takes, and that's what we're solving for. We're solving for t, which is time. So now I'm going to plug in what I just said into the formula. Let me make sure I'm doing this right, actually. Okay, yeah. So 62.5 will be in the front, equals 500, 1 divided by 2, t divided by 4. So this is what we have. This is the remaining amount. This is the initial amount. This is just 1 divided by 2. We don't have time, but we do have 4 for 4 hours. So we're going to just solve this now. We don't have the true exponent form yet, but we can do 500 times 1/2. And that will be, no, wait. We divide everything by 500. So we're going to divide this side by 500 and this side by 500. And that crosses out. 62.5 divided by 500 is 0.125 equals 1/2 to the power of t divided by 4. So that's what we have now. And this decimal can be converted to 1/8. So now we just solve for t. So now we have 1/8 equals 1/2 to the power of t divided by 4. And from now on, we have to make this to where it has an exponent, so we can solve for the exponents. That's just an easier way of doing this. So you could say 1/8 is the same as 1/2 to the third power. It means the same thing, equals 1/2 to the power of t divided by 4. And now we can solve for just the exponents. So you get 3 equals t divided by 4, and you may automatically just solve it. What divided by 4 equals 3? It would be 12. And that's your answer. So it takes 12 hours to reach the remaining substance of the initial substance. And yeah, so some questions you may have, or some problems you may have when solving things like this would be mixing up the initial amount with the final amount, like the remaining amount. Sometimes people get, especially because the formula has A's in it, like I sometimes honestly flip them and it kind of changes everything. It gives you a completely different answer. So make sure you don't do that. And I guess you could use this in medicine. I know, like, dealing with grams and milligrams, that honestly reminds me of medicine, and I feel like you can easily get half-lives in that, and you need to know your initial amount and remaining amount with your medicine and how long the medicine will last and how long it's good for. Like, this is perfect for pharmacy and stuff like that. So yeah, anyways, thank you.